Hello, I'm Dr. Ron England, and we're going to look at lookup tables. And first I'm going to go over kind of what the concept of a lookup table is. So on the screen here, I've actually got an example of a lookup table. And the way this works is, if you look over here, you'll notice you have a series of, you have a column, which is actually, is the numbers for the lookup for values within this row, within the rows. But it's a single column. Here we have a row which has a series of values, which is the lookup values. So essentially this is a row header and this is a column header. Okay, so in this case though, however, the row header and the column header are numeric, because what we're going to be able to do is use them to look up values. And then we have a series of values. So as you can see, this is a two-dimensional table with a header here and a header here. Now, if I wanted to look up a value, let's say I knew that the value of the row was 40, and I knew that the value of the column was 20, I would simply go over here and I would pick out this value, 0.181, and that would be the actual value I would be pulling off of the lookup table. But lookup tables that are numeric have a little bit more complexity than that, because you have to get into the concept of interpolation. What if the value was 37? Okay, which sat between 35 and 40, and 17, which sat between the 15 and the 20. Well, in that case, what we're going to do is we're going to look at this concept of one that's been coded to be able to do this interpolation, and I'm going to go over how that interpolation works. So for this one here, we're going to go ahead and make this so you can see it. But if you look here, I think I gave the example of 37. I gave the example of 17. And then I want to be able to calculate and get a specific result. So 0.1534, and then I actually showed down here this thing that's a lookup row, which is the row it actually creates to look it up. And you'll see that when I go over the calculations. But let's look at how that worked. Okay, so 37 and 17. Let's go down. This is the same table, by the way. 37, okay, and 17. And you can see that the numbers should fit within this 4-range block. Now my result was 0.1534, which sits nicely in that series of numbers and is actually the interpolation on both the row and the columns of how you, the rows and the columns, and gives you a final value. That in itself is the concept of a lookup table. And lookup tables can be very valuable when you're trying to work with large sets of numeric numbers in 3 dimensions or 2 dimensions. So let's go into the code here and let's actually kind of look at how we do this. Well, first I've abstracted this concept of a lookup table, and I have some comments here. And I have some information here. And these are very basic. So we have row title, row description, row data, and row data decimal places. And those should all make sense. Those are properties of this. And then the same thing for the column. The column title, column description, column data decimal places, table data, and table data decimal places all should make perfect sense, that you actually have to keep track of how many decimal places do they have, the titles, the descriptions, and the data. Now, if you notice, I actually have the data as a string. The reason I do that is I'm actually inheriting this from XML property object, and I keep basically arrayed information in a string, and I keep it either tab or new line delimited within the string. And then I have all the methods necessary to convert those back into actual arrays. So how do I do this if I'm doing a calculation? So let's look at this. I have the function here, calculate. And the first thing I do is I make a variable of the row values that I convert from the row data, which, remember, it's a string. So I have a variable which is going to be an array of type double. And then the next thing I do is I create this row interpolated, and I pass it the row value and the row values. Well, the row values is the actual, the values right here, okay, these numbers right here, okay? And then the number that is the actual row value that I'm going to use for the interpolation is the number that might sit within the middle. So in other words, in here, in this case, I would have 30, 35, 40, 45, and that row value would be 37. So I'd have to interpolate a new row in there so that I can do the interpolation on that axis. It may sound complex, but in reality, you've seen it. The interpolated row is this row down here that I used, which actually sat between 35 and 40. It had interpolated values for every column. The beauty of that is it allows me to interpolate within this individual single dimensional array to get the column value on its interpolation. So I do this by doing create interpolation row. Well, let's go over to create interpolation row and kind of look at how that actually works. Because if you can understand that, you can actually get the entire thing done in the interpolation row. So first thing I have to do is I want to find the index, and that would be the index of the row that is the one just before the number. So in this case, if I had 37, I would want the index of the 35, which in this case I can easily look at and say it's 0, 1. Okay, well, it's going to be in this case B1 because it's 0 indexes. 30 would be 0, 35 would be 1, and it'd be between 1 and 2. So the row index that's the one just before it is 0. Well, how do you do that? So let's go to the implementation of the row index. So what I do is I actually start at the highest value. First I check to see if it's less than the lowest value, then I return a 0. If it's and actually in that case I could actually that would be the index, and I want to return the index of the one that goes with it. So I start at the highest value. I start with I do a for loop, and I start at the highest value. And as long as the value is greater, as soon as the value is greater than the value of that one, so it's going to go. I'm going to start at the highest one. So I'm going to start at 98 here, and I'm going to go down 98, 95, 90. My value is 37. So as soon as I get to a number where the value is greater than the number of that index, I know that that's the index. So I work my way downwards and I find that index. So that's how that index works. Okay. Now the next thing I have to do is, once I have that index, is I need to find an interpolation factor. What's an interpolation factor? Well, it's actually something very simple. If my number is 37 and it's between 35 and 40, well, let's make it easy here. If this was 37.5, it sits halfway between 35 and 40, your interpolation factor is 0.5. 0.5 essentially says it's halfway between those. So the interpolation factor is simply a factor that says how far between these, where does it sit, an index from 0 to 1, how far does your number actually sit between those two values? And it's simply a matter of, now in this case I have to take into account that I might have to even extrapolate the number, but for interpolation it's simply taking the value minus the base value over the value of the upper one and the lower one. What does that mean? Well, in this case, in the 37 example, it means 37 minus 35 over 40 minus 35. That's going to be my interpolation factor. How far above that 35 am I? And then that interpolation factor is then applied to the numbers in the data. So in other words, if I want to find the number that, like if it's 37 and I want to find the number in this column that coincides with that, well, the difference, I take the 0.009 and I add to it the interpolation factor times the difference between those two, and I have the number in between those. And that's just simple interpolation. Now, what makes the two-dimensional interpolation challenging is that I actually have to create an interpolation row. I have to create a row for every column. So this 0.011, well, if I look at 37 here, 0.009 and 0.014, the 0.001 is the interpolation between those two. So now, when I go back and I look at this with this lookup row, and I look at my column is 17, well, 1, 0, 1, 2, 3, 0, 1, 2, 3, 0.137 here, and 0.179 are the two values for the interpolation of 37. I've created an artificial row between the 35 and the 40 row, and now I'm going to interpolate using the 17 between these numbers, which gives me the 0.153, and I do it in exactly the same manner. So in the case of doing a lookup table, you're really looking at two steps here. You've got the 35 to the 40, which you do the interpolation, create an artificial row. With that artificial row, you now interpolate on the column, and you put the whole thing together. Everything else that actually is built into this object is simply to help with the individual formatting and on the conversion of the string values into the array values, which is what you have to use for the interpolation, and also keeping track of the decimal places so that you can actually have this nice looking output. Notice that the output is nice. This is a single decimal place, are 0 decimal places. This is 0 decimal places, and this is 3 decimal places. And if you're going to have nice looking output, you've got to be able to specify those. But putting all that together, you've got this ability to code a lookup table. Now, the code for this lookup table is going to be available on the COP 4834 website that goes with this lecture page. And hopefully, if you're trying to do lookup tables in two-dimensional or three-dimensional, well, in this case, two-dimensional interpolation, you have this capability. Now, I actually have examples within the SMATA code where I do multi-dimensional interpolation, literally in 3 dimensions and 4 dimensions. But in 3 to 4 dimensions, it's just simply creating now, like in a 3-dimensional interpolation, you're actually going to create a lookup table from the 3 dimensions. You're going to interpolate on that 3rd dimension and create a lookup table. In 2-dimensional interpolations, you create an artificial lookup row. Okay, in this case, I create an artificial lookup row. And so you've got this ability to do multi-dimensional as long as you understand the concepts of interpolation and 2-dimensional. Hopefully this has been very useful for those who want to do 2-dimensional interpolation and you can understand the steps. And good programming.